Hello everyone, my name is Tudor Sasaran and I'm a candidate for Masters of Science in Biomedical Engineering at Arizona State University. This presentation is about my culminating project. The project is entitled Compensation Mechanism for Fatigue-Induced Eye Movement Degradation. First, I would like to give you an overview of the whole project. The motivation behind it revolves around our contemporary lifestyle, in which we spend a lot of our time doing heavy cognitive work while oculomotor fatigue is induced. The hypothesis is that there is a compensatory mechanism triggered by eye fatigue that maintains an adequate level of performance by means of visual information extraction optimization. In this study, gaze parameters, facial expression, and electroencephalography were recorded from several esport gamers playing Counter-Strike for up to 3 hours. We concluded the existence of a cognitive performance compensatory mechanism that is triggered by eye movement fatigue. Data collected was through EEG, eye tracking, and facial emotion recognition algorithm. The EEG measures electrical brain activity from which cognitive emotional metrics were derived, such as excitement, engagement, stress, and interest. From the eye tracker, saccade duration, angular velocity, and fixation time were derived. Affectiva FDEX uses facial emotional markers to derive fundamental emotions, such as anger, joy, and sadness. All these sensors were synchronized by a program called iMotions. For the study design, we invited our participants in the lab, and the setup was done. The picture shows a subject playing Counter-Strike while parameters were recorded for approximately 3 hours. First, we wanted to show that oculomotor was indeed induced by the task. Saccade duration is the time it takes for eyes to rapidly move between two fixation points. And it was seen to be increased in average by approximately 60%. Moreover, a decrease in fixation duration and a decrease in angular velocity provided additional support to the proof that oculomotor system was fatigued. The cognitive compensatory mechanism would come into the equation only if the performance in the task would relatively stay constant during the 3 hours of play. Here, it is shown that the score, which is performance, of the players is in average constant, even if the eye performance is degraded. One of the significant changes in the cognitive performance was found to be the level of engagement. Engagement is characterized by increased psychological arousal, or alertness, and immersion in the task. And it was found to be increased as the eye performance decreased. The emotional impact over time is a negative one, as cognitive compensation probably gets triggered and modulated by emotions. This concludes that emotion seems to lead to changes in cognitive response. In the graphs, we see how the level of anger and engagement increases over time. The hypothesis was confirmed. Eye fatigue seems to be compensated by cognitive processes. Engagement increases to compensate for decreased eye performance and is triggered and modulated by emotions. Future studies will investigate when the threshold of fatigue is surpassed and elevated performance can no longer be maintained. And this concludes my presentation. Thank you for your time and attention. Special gratitude for the help needed completing this project goes to my mentor, Dr. Aurel Koza, and my committee, Dr. Marco Santello and Dr. Stefan Helms-Hillary.